conjunction with the National Land Care Program, we've been looking at phosphate use efficiency for the last 2 years. Phosphorus is a finite resource, and phosphorus is used extensively in farming. Phosphorus is also a waste product in wastewater and is responsible for algal blooms and dead zones. So it's very important that we can reduce our environmental footprint from agriculture, and at the same time to have a product that's being wasted to the environment that we could otherwise recycle seemed like a wasted opportunity. So we've got a product that's finite and we're running out of, at the same time as being wasted. A company called Ostara developed a process for wastewater treatment plants that would extract the phosphorus out of wastewater, cleaning up the environment and also recycling this valuable agricultural commodity. Ostara produced a product called Crystal Green. Crystal Green is a magnesium ammonium phosphate with an NP ratio of 5:12. Importantly, what differentiates it from a number of other recycled products is its materials handling. It's very hard and durable, it can be transported easily, and it can be drilled out of industrial sowing and farming machinery as per normal fertilisers. We think this is a massive breakthrough with Crystal Green, is simply that handling and durability. Another important factor of magnesium ammonium phosphate is that it has a very low salt index, and that is the amount of water that fertilisers draw into themselves to become wetted up. Now, having a very low salt index is important, particularly in disc seeding systems where we have narrower and narrower sowing slots. So previously in history, where we used to work up the whole ground and have fertiliser and seed mixed through the whole ground, the chance of a fertiliser granule and a seed granule being next door to each other and the fertiliser desiccating the seed was very low. As we moved into no-till and then into zero-till seeding systems, where our seed bed row becomes increasingly smaller and we're using fertiliser and seed in this confined area, that increasingly we have issues with fertiliser toxicity. By reducing the salt index of our fertiliser, we reduce the effect of that salt toxicity. We've tested it against diammonium phosphate and monoammonium phosphate, which are traditional standard industrial fertilisers, and we found its performance is excellent. Even though its nitrogen to phosphorus content is 5:12, which is lower than the other fertilisers, it's actually produced the same or more grain in our trials, showing that its actual phosphate use efficiency is significantly better. The ability to use phosphate efficiently is increasingly important because it is a finite asset and its supply is very much tied to input cost. So having a low salt index is increasingly important in disc seeding systems. What we've been finding in our trial work is that the Crystal Green transports well, handles well, has a low salt index, but in addition performs quite well.